Okay, now we're going to tackle verifying identities. I know this kind of messes with your brains, a lot of you. Here's the important piece. Use the identity sheet to help you. That should be right next to you as you're trying to solve these. And then here are some other tips. Break pieces into separate fractions when that's applicable. Remember to look at the identity sheet. Use the fundamental trig identities to rewrite things as sine or cosine. So for example, if you see tangent theta, you could rewrite that as sine theta over cosine theta. Now, when you're doing that, you always, even though you're not going to change anything on the other side, you always want to look at what the end goal is, because maybe there is a tangent theta in the numerator. If there is, you wouldn't do this step. But if there's not, you would rewrite tangent as sine over cosine. So that's just kind of a word of caution there. Okay? And simplify each step as you go. And remember, you've got to, on the other side of the equal sign, you're not changing this side. You're not changing it, but you are stating the reason. So if you saw Pythagorean theorem, like if you saw sine squared theta plus cosine squared theta, and you rewrote the next step, you put 1, well, that reason would be Pythagorean theorem. All right. And then remember, you're only changing one side. So let's do an example. So look at what we have. We have sine 2x or 2 theta plus 1 plus cosine 2 theta. And then it equals all this stuff over to the right. And I don't even care about that really. I mean, I'm going to pay attention to it, but we're not changing anything on this side. First thing I want you to pay attention to, notice this said sine 2 theta. That's a double angle. That's a double angle. And then we're going to look over here. We have a sine and cosine and a cosine. So when we look at the identity sheet, sine 2 theta, we can rewrite as 2 sine cosine theta. And cosine 2 theta, because there's this plus 1 here, I can get rid of that by this subtract 1. And because this has a cosine and this has a cosine, I know that at some point I need a cosine squared. All right, so let's go ahead. I'm going to rewrite, whoops, sorry about that. I'm going to rewrite the sine 2 theta as 2 times sine x cosine x and then plus 1. Now this cosine 2x, I'm going to use this identity. 2 cosine squared x subtract 1. And the reason that we're going to give for that, we converted these, we used the double angle identity. And now, because we've done that, we can cancel the 1's. And then the reason that, we just simplified. You could put combine like terms. That could be a reason. I went ahead and put simplified. Right? So now, let's see. We have this entire term and this term, and we know that there's 2 separate because there's a plus sign between them. Well, they both have a 2 in common, and they both have a cosine x. They don't have a cosine squared in common, but they do have a cosine to the first power in common. So we're going to factor out a 2 cosine x, and then when we do that, the 2's come out, and this cosine comes out because 2 sine cosine theta divide 2 cosine. It's just going to leave the sign. And because this is cosine squared divide cosine leaves a cosine. So what is left in the parentheses is sine plus cosine. And that's what we're going to put in the parentheses. And the reason we did that, we factored. We factored out the 2 cosine theta, Now look at what we have. 2 cosine times sine x cosine x. Well, that's what this side says, so we're going to rewrite the left side, and ta-da, we're rewriting the next side, and we're done. All right, that's it for this one. But every one of these verifying identities are different, but the process is the same. You have to use the identity sheet. Rewrite things as sine and cosine. Make sure you're knowing why by using the identity sheet. This time we use the double. Anyway, back to that's it for this one. All right. See you at the next video.